In the previous episodes, I showcased the printhead and docks on the floating bar mechanism. In this episode, I will provide a detailed account of my findings and modifications. Hi, welcome to Slow Engineering. I'm David. I put together a shuttle with a tool head for the initial test assembly of the printhead. At first, it looks okay, and the bushings and pins work well within certain tolerance combinations. However, I encountered an issue when aligning the floating bar with the XY gantry. When I lowered the floating bar to find the lowest docking position, I realized that the nozzle on the printhead wouldn't reach the print bed due to the design of the Z-axis. The Z-axis mechanism has a spherical surface for core gantry leveling, and its height sets the lowest positions of the gantry. To address these issues, I redesigned the shuttle to lower the printhead. I also considered adding a second linear rail for stabilities or changing the path of the cooling ducts. However, these changes are not critical and greatly beneficial to the design. Therefore, I focused on lowering the printhead with the shuttle. With this change, the toolhead control board has to move up slightly. This led me to consider whether the drivers on the board was reliable during printing, as I knew the drivers were temperature sensitive. While placing the control board inside reduces the wiring, I have concerns about its reliability. If you have any insights, please comment below. The control board solution probably has covers to protect against direct contact, but ventilation is still necessary. At the extruders, I removed the PTFE tube connector sections and had a larger hose for the PTFE tube to insert directly. The original design required a heated bronze ring in the hull to install the connector. However, sufficient depth of the PTFE tubes inside the extruders will provide a similar result. The same concept applies to the lower sections between the extruders and the hot end. These modifications will reduce filament frictions from the 3D printed parts and result in smoother movements. On the other hand, I realized that the printhead's movements in the Y direction is limited, which affects the positioning of the floating bar and the location of the docks. Previous concepts for the shape of the docks won't work because they need to accommodate the toolheads within the printhead's reachable range. More viable solutions exist than moving the DIN rail closer to the printhead. An alternative option is to make the docks longer to allow access to the printhead. While making these decisions, I also examined the movement of the docks when the door is rotated to ensure that they do not obstruct the door's opening. These assessments confirm a 3mm distance between the printer's front frame and the door. Considering the previous suggestions, I used the Clicky-Clack fridge door as the door hinges and handle. The door rotating radius seems acceptable, and there is no interference from the docks. I extended and added more features to the docks. The arms are printed separately to enhance stability, and chamfers are included to improve printability. I modified the model to fit the standard screw length and heat insert dimensions for locking. Then cut the lower part of the arms to accommodate the heat block sock. On the other side of the DIN rail, the front part has the proper tolerance for sliding onto the DIN rail, with the spacing part forming a 3D locking into one piece. The holes near the arms are for docking the toolhead. Two in the centers are for magnets, and the outer two holes are for screw heads. The extruders will be attached to the arms and held in place by magnets. I used ABS for the prints. They are solid and sufficient to support the toolhead detaching process. Here are some improvements for the printhead and docks. If you have any ideas about better features, please comment below. Now I'm concerned about how the wires go for toolheads. Where do the other ends of the toolhead cables go? As always, moving forward.